So I put this paper up, 2018, I believe. A comparison of J. Scott Armstrong's Arthur's formula with stellar metamorphosis. There is a formula for achieving publication in scientific journals with stellar metamorphosis, and stellar metamorphosis ignores these. Explanation is provided with links. This basically are more lessons that I learned. These are very valuable lessons I think any young researcher should learn to navigate their careers with. Don't be like me, in other words. Now, there are six things you need to do to get published in a mainstream journal. Don't pick important problems. Don't challenge existing beliefs. Don't obtain surprising results. Don't use simple methods. Don't provide full disclosure. And don't write clearly. Now, the antithesis of that is I thought in order to really be a great scientist, to be a real thinker, somebody who could shake things up and make a real difference in the world, I thought the total opposite of those ideas was what you needed to do. I thought you needed to pick an important problem. I thought you needed to challenge existing beliefs. I thought you needed to obtain surprising results, or at least strive to get something that's new out there. I thought you needed to use simple methods so that they can be repeatable in other experiments. I thought you needed to provide full disclosure at how you arrived at your conclusions and what types of materials you needed to get those results out there, as well as the people involved in the experiments or inside of the projects you were working on. I thought, full disclosure, full transparency was the name of the game, but it's not true at all. And I also thought in order to be a great scientist, you needed to write clearly. And that's one of the other big lies. In order to get published in a mainstream journal, you don't want to write clearly. You have to make things as obtuse and as complex and as riddled with as many heavy math equations as you can. That way, the people, they look at, this looks intelligent, But basically, I'll review some of the ideas here. Hi, Celeste. Don't pick important problems. And I have here, how planets form is a very important problem. How stars evolve is also important. How life began is important. Why life evolves is important. How much life is in the galaxy is important. Figuring out if we are alone in the galaxy, that's very important. All these are very important problems and are red flags for journal editors and the powers that be. If you want to get anything published, don't pick important problems. Pick ideas that are forgettable, that nobody really cares about. That way you get published. If you pick an important problem, then you have too many sets of eyeballs on it. You have too many people asking questions. You want to maintain a low. You don't want to be skylined. In other words, imagine a mountain, and there's a sniper looking for you. You don't want to walk along the edge or top of that mountain, because then you skyline yourself. You stick out like a sore thumb. You make yourself a target. In order to not make yourself a target in the scientific community, you want to make sure that the ideas that you talk about bring it down low to the ground so nobody can see that you're there. That way you don't make yourself a target, and that way the journal editors don't have their credibility challenged. So why did you have somebody like this publish a paper in here? They're clearly crazy, Crazy. Number 2, don't challenge existing beliefs. Stellar metamorphosis challenges many beliefs. And those beliefs that it challenges are that planets and stars are mutually exclusive objects, life has no purpose and evolution has no direction. That's false. Life does have a purpose and has direction. Fusion happens in stars. No, it doesn't. It happens in AGNs. Life formed in outer space and was transported here. No. Life forms as a direct result of stellar evolution itself, as a star becomes a cooler, older star called a planet. Asteroids and comets bring water to planets. False. The star cools and collapses, and the oxygen and hydrogen combine, making water. The star is what creates the water world as it evolves over many hundreds of millions of years. It wasn't transported here from comets. That's ridiculous. Asteroids in the solar system are the remains of planets forming. No, the remains of planets being destroyed. All the objects in the solar system are about 4.5 billion years old. No, all the objects in the solar system are vastly different in age. The solar system is a singular object. No, the solar system is tens of thousands of objects. The Earth was always this size, density, composition, and differentiation, along with every object in the solar system right after they were formed. No, they're evolutionary structures. They are in one stage or of another of their own evolution. So basically, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9 plus many other existing beliefs that this theory challenges. And being that every single one of these beliefs is something that challenges the mainstream beliefs, I'm never going to be able to get published in a mainstream scientific journal because they don't want people to challenge the existing beliefs. It makes them look bad. Too much challenging going on. In fact, any challenge at all is deemed a threat. No publication for you. Either agree or give up. Resistance is futile. In Armstrong's words himself, to challenge existing beliefs is folly. As a scientist, it doesn't pay to challenge existing beliefs. It's the complete opposite of what I thought it was when I was a young man, when I was younger. When I was in my 20s, I thought if you challenge the beliefs and you can shake things up a little bit, you can get people to think about the problems differently at the very least. But that's not true at all. What they do is mainstream scientists, they close down. They shut you down. They blacklist you. They peer review you out of existence. You cannot have a career if you challenge the beliefs that they have. To them, it's an insult to their intelligence, and it's a threat to their careers. You do not want to challenge their beliefs. That's the no-no. A big, big, big no-no. If you're going to challenge their beliefs, you have to do so in other forums, such as YouTube, like what I'm doing, or on Vixar, where you can write papers that challenge the mainstream beliefs. If you try to get something published that challenges their beliefs in a mainstream journal, it's never going to happen, you see. They weed all those people out through the peer review process. It doesn't matter how incredible the idea is. It doesn't matter how correct it is. It doesn't matter how many mysteries it solves, which is the naivety in most people. They think, well, if it was a great idea, then the scientists would see it and it would get published in the mainstream journal. No, it's not true at all. They weed the great ideas out that conflict with their existing beliefs. So don't challenge existing beliefs if you want to be published in a mainstream scientific journal. Go along with the crowd, swim along with everybody else, keep a low figure, don't skyline yourself. Number 3, don't obtain surprising results. The main surprise here is that astrophysics has not been developed yet. They're not learning meat and potatoes information in school. They are doing the old smoke and mirrors routine with math equations. How can they be learning astrophysics when they don't even know what they're looking at? As well, how does one get approval from an editor to publish a paper or idea that essentially renders a very large portion of their hard-won, energy-intensive educations obsolete? I even extended a friendly arm out and said, listen guys, we're going to have to go the route of continuing education by sending emails back in 2011. I remember when I tried to tell working astronomers about this major discovery back in 2011, but most of them ignored me. Some of them responded with ridicule and, what have you. Because, this goes back to number 2, don't challenge existing beliefs. They find it insulting if you say something new that conflicts with what they believe. It's an insult to them. Scientists aren't these open-minded people. We'll get to that in a second. These scientists, they've just finished off paying their student loans and are established teachers and researchers now. Nothing can surprise them. The whole, scientists love surprises is false. They hate surprises. Trying to publish surprises will get you stonewalled by journal editors and peer reviewers. And that's another really important lesson I learned. I remember watching the Discovery Channel and listening to these scientists talk on these programs saying, oh, well, we love surprises. We love to be shown that we're wrong about something. No, they don't. They hate surprises. Surprises scare the out of them. I don't want to say that word. If anything, they're outright paranoid of surprises because it means other things down the line have to change and they have to rework everything. And that just takes so much work and so much time. As well, it has a possibility of ruining their credibility in case it's a really big surprise. Scientists don't like surprises. They don't like change. And those are the two things that they try to tell people in propagandistic terms like, oh yes, we love surprises. We love to be shown that we're wrong. No, that's total nonsense. They don't like to be wrong and they don't like surprises. Number 4, don't use simple methods. I was wrong, and more wrong. I drew a line connecting sun-like stars to Earth-sized objects. I did a second grade connected dots diagram. This is the connected dots diagram, mass versus radius. These are young hot stars that are really big, and they go down a predictable curve right down to the very bottom. Every single star in the galaxy can fit on this little graph right here. And it's pretty obvious. You just draw a line, that's where star evolution happens, because that's what planet formation, it's the same thing. Where's the prestige in that? Where's the prestige in making a second grade connected dots diagram? There's no prestige in that. You mean you take two dots and you connect them together with a line? How scientific is that? You're not a real scientist. Fact is, simplicity does not get published because it makes others look really, really bad. How dare you accept some second grade connected dots in a prestigious journal? Don't they know the acronym KISS, Keep It Simple Stupid, was reportedly coined by Kelly Johnson, lead engineer at the Lockheed Skunk Works, creators of the Lockheed U-2 and SR-70 Word Blackbird spy planes, among many others? They don't like things that are simple. Simple doesn't pay the big money. You have to make things as complex as possible. Complexity pays. Just like in the finance community, you have derivatives on top of derivatives, on top of derivatives, on top of hedge funds, on top of derivatives. The more complex you make those investment tools, the more money you can probably make on them. And anybody should know that if they take finance classes. It gets really wild out there. And then same is true with publication. If you use simple methods and people can understand those methods, then those people that are on down the line making things really complex, it makes those people look bad. And the group mentality is, if it's not complex, then somehow you've done something wrong. Because they have the mentality that if it's complex, then it's probably more accurate. But that's totally false. Sometimes the answers in life are incredibly simple and easy to explain. But yeah, it's a big problem. If you use simple methods, you're not going to get published in a mainstream scientific journal. You have to make things as complex and as obtuse as possible. Number 5, don't provide full disclosure. I've made hundreds of videos on YouTube and discussed everything I've gone through during this process. All information that I have obtained is freely available in the local library and the internet. Journal editors and peer reviewers don't like when their sources are exposed, I guess. Who knows why this rule is there? Full disclosure. I guess where it is you got your money from. Who gave you the grant money to study such objects? And if you're wrong, it puts those people that gave you that money, it puts their credibility on the line as well. I guess they don't like being exposed in that regard. And finally, number 6, don't write clearly. This is a huge problem I noticed in many papers on arXiv, which is the Cornell version of Vixra. It's the reverse of Vixra. Cornell likes to blacklist people. They like to censor people. That's not what it means to be a scientist. If you blacklist people and you censor people who have ideas that are scientific in nature because you're not a part of the big club, you're not a scientific organization anymore. Most papers on arXiv are wordy and extremely difficult to read. I like to think I have an unlimited reading capacity given modern English is used, but seriously, why make things difficult to read? If you have a point to make the point. Why add a bunch of unnecessary words and math equations? To make the paper pretty? All in all, hard lessons learned. If you want a career in the sciences, do what the career scientists do. When in Rome, do as the Romans. Basically is what I'm saying. If you want to make great discoveries, do what the great discoverers do. Question assumptions and ignore large portions of what the career scientists do, not all of it, just a lot of it. In other words, if you do see something that's really important, really valuable, and it's scientific, for God's sake, publish it. Write it down. Get it on Vixra. Don't bother with trying to get approval from these academics where their mentality is off in la la land, or they're more obsessed about their career advancement than they are actual science. And basically, I think that sums this talk up. But all right, I'll link this paper to the bottom. Hopefully, more people read it. It only has like 36 views, but it's whatever. There you go.